So hi, hello and welcome again, and today in this video I want to explain to you what oxidation and reduction reactions are. You can also refer to them as redox reactions, reduction, oxidation, redox. And I'm going to explain this concept of oxidation and reduction using a potato here. And this potato is supposed to symbolize electrons, high energy electrons, okay? And that's basically high energy electrons, and my two hands over here are molecules that are able to carry these electrons. So my left and my right hand, they're able to carry these electrons because these electrons cannot simply float around in space alone, but they're always bonded connected to a molecule. And you can now see that these high energy electrons are now in my left hand, and therefore my left hand, because it carries these electrons, is referred to as being reduced. Substances that carry high energy electrons are referred to as being reduced, and the other hand over here, the other substance, is oxidized. Okay, and in a redox reaction, what happens is that these electrons are now transferred from one substance to another substance, and look what happens. This substance gives off the electrons and passes it on to the other substance, and now this substance is oxidized, and this one here is now reduced. Okay, so that is basically it. Yeah, and the important thing is to understand that an oxidation and a reduction always have to happen together. If one substance is oxidized, then the other one is reduced. Okay, because those electrons are always associated with molecules. So you need some kind of electron carriers that carry those electrons, and they can be oxidized and reduced. Okay, this is a very, very common and a very important biochemical or chemical step, and I'm going to now explain to you how you can write this down using some proper chemical notation. And once we understand that, all of the following videos will be much easier to understand, because it's always the same thing. Yeah, it's going to repeat. And what I'm going to do now is I'm going to simply write down, not the name of a substance. I'm just going to call it substance A. And this substance A is, let's say, oxidized, so I can write a small OX beneath it, and it becomes substance B. And let's also call it A. Yeah, let's also call it A. We wipe this off just for the sake of consistency. And this substance A is reduced. Okay, and what do I need to do? What needs to happen for this to happen? Well, you need to add electrons. Okay, so I write abbreviated E minus. That's my electron, and I have to add this electron, and then substance A becomes reduced. So that is one way of writing it. Yeah, and the other way around is if I want to go the other direction over here. Yeah, that's also possible. Then of course electrons have to be removed. Okay, so the reduced state over here, you remove the electrons and it becomes oxidized. So that is basically one way of writing it with those small letters over here, oxidized and reduced. But that's not a very common way, really. I personally don't like it so much. Sometimes it's also not necessary, because one thing that you have to understand is that those electrons, they cannot simply be given off and taken away like this, but they also need those so-called electron carrying molecules. And there's a very important electron carrying molecule called NAD. It's an abbreviation, of course. Okay. Nicotinamide adenine dinucleotide. I love these words. Okay, or some people also call it NAD plus. It's the same thing. And this NAD plus is now able to accept electrons, 2 electrons as a matter of fact. And when it accepts electrons, it is able to become NADH. Okay, so it is. What happens is it's NADH, and in order for this to happen, you need to add electrons. Okay. E minus, and so you see that the NAD plus, this is in the oxidized form, and the NADH is in the reduced form. So some people also write it differently. They don't write NADH, but they say reduced NAD. Now I don't like using this, because reduced NAD is the same as NADH, but it's much more to write. Yeah. I would actually prefer I prefer always using NADH because it's clear that it is the reduced form. Other people also write it differently. NADH plus H plus same meaning. Okay. I think even I've seen NADH2, which is, I think, strictly speaking, not quite correct, but it's also possible to say that. Yeah? But in any case, the important thing is that this NAD is an important electron-carrying molecule that we're able to use to pass electrons between substances. And I'm going to show you now how this can actually happen. Yeah, so I'm going to erase this again, and what we have now is we're converting substance A and to substance B. Okay, and let's say that this here is an oxidation step. And when I say an oxidation step, then I refer to the substance here. This substance over here is reduced and then it's oxidized. So it's an oxidation step. And if I want to oxidize it, I have to remove electrons. So what I do is the following. I'm adding NAD plus. Okay, I'm adding NAD plus and I'm taking away NADH because the NADH contains electrons. Electrons are in here. Yeah. And when I do that, then the NADH is now reduced and substance B is the oxidized form. Yeah? That's one way of actually saying it. So this is an oxidation process. So A becomes oxidized. Yeah? So it's oxidation. Now you're going to say, well, actually this is oxidation, but this one over here, NAD becomes reduced, of course. Yeah? But when I say this is an oxidation reaction, I always refer to the main substrates that I'm actually talking about, which is the A, which loses electrons to become substance B. Yeah. So this is actually a very common thing that happens, and however there is a shorter way of writing it. I do not need to say that there is an NAD plus here because it's kind of clear. So what I can simply say is the following. I say A becomes B, and I simply remove NADH, and that's all I need to say because it's clear that I have to add NAD plus. Okay, it's absolutely not necessary for me to indicate this. So but simply by looking at this, I already know it's an oxidation process. Yeah. So this is a very common thing. However, this is sometimes accompanied with a second process that I need to explain to you. Okay, and the second process is a so-called a decarboxylation process. Now, what is that? Well, sometimes I'm not only removing high energy electrons this way, but at the same time, I'm also removing a CO2, carbon dioxide. Okay, I'm breaking down A by splitting off one carbon dioxide, and at the same time I'm removing high energy electrons, because when I break down substances, the energy in the bonds is released. There's energy released, and where does the energy go? It goes into the form of high energy electrons and the energy is caught then in the NADH. Yeah. Remember the law of conservation of matter and law of conservation of energy. You cannot make or destroy matter. You cannot make or destroy energy. So if A has a lot of energy and B has less energy, well, where did the energy go? Well, it is stored in the form of high energy electrons in NADH. And if a split of carbon dioxide, well, where does the carbon dioxide go? Well, it's released here, and then it probably goes into the blood, it's exhaled ultimately. But this also means that if this, for example, is a C6 substance, then how many carbons does B have? Well, it must be a C5 substance, because 5 plus 1 carbon over here gives 6 carbons. If I remove 1 carbon from here, then essentially I know that what's left over must be a C5 substance. And if you simply remember this, then you can easily trace back and calculate the number of carbons that you have. Yeah. So again, this is a very important process, and I need to write down the name here because it's so important. This stage when you remove electrons and when you remove carbon dioxide is referred to as oxidative decarboxylation. Again, I have to move the microphone a little bit out of the way here. Decarboxylation. Okay, so decarboxylation means the removal of carbon dioxide. So decarboxylation, removal of CO2, and oxidation is the removal of electrons. Yeah, and this is basically both of this happens here. Yeah, you remove electrons and remove carbon dioxide, and we get a different substance here. Okay, B is a different substance than A. Yeah, different chemical substance because we removed CO2. Yeah? Very important. And if you simply remember this, it keeps on reappearing over and over and over again. And this is how essentially organic molecules are broken down in cell respiration. By subsequently also by oxidative decarboxylation, and then this NADH stores now the energy, and later on we have to convert it to ATP, but that's something I'm going to explain in a different video. So what I'm going to do now is I'm going to simply summarize the important points here again of what oxidation and reduction is. I've made a couple of sheets again over here because so what is reduction? Well, a reduction can also be considered the removal of oxygen, but that is a little bit an outdated definition. So it's actually much better to focus on electrons. So a reduction process is the addition of electrons to a substance and associated hydrogens. In many cases, or in some cases, not only electrons are passed on, but also hydrogens. Okay. And oxidation is the opposite process. Again, the addition of oxygen to a substance, it's a little bit the outdated definition, but oxidation is the removal of electrons and associated hydrogens. Yeah? But again, let's focus on the electrons here because that is actually the important one. Yeah, and this basically explains what so-called redox reactions are. And I hope with this little introduction into redox reactions, we have a good basis to better understand the next couple of steps not only the next couple of steps, but generally cell respiration. And I think I'm just going to leave it at that and wish you all the best, and bye-bye.